Okay, so now we have problem 3. Okay, this problem is actually based on the logistics regression, which has the binary response variable. Okay, either 0 or 1, 0 for the failure and 1 for the success. Okay, so the question says that a researcher is analyzing a binary response variable using logistics regression. Okay, so two models are considered here. Okay, a reduced model, okay, and a full model. Okay, so we have a reduced model and we have a full model. Okay, so the reduced model, it contains only the intercept term. Okay, and the full model, it contains the intercept plus the explanatory variable. Okay, so it contains both. Okay, and the reduced model contains only the intercept term. Okay, so the models are actually nested. Okay, so the nested model, okay, it means that the reduced model is obtained from the full model by setting the regression coefficient equal to 0. Okay, so for example, we have a full model. For example, this is an example. Okay, so the full model, it may be like y estimate is equal to beta naught plus beta 1 x1 plus beta 2 x2 plus error. Okay, but the reduced model, okay, for example, we want to check only the effect of the first variable. Okay, so we ignore the second variable. So this coefficient of the second variable, beta 2, okay, beta 2, it is taken as 0. So the reduced model, it can be like beta naught plus beta 1 x1 plus epsilon. Okay, so this is now the reduced model. How we got this? We got it from the full model by setting one parameter, okay, one regression coefficient equal to 0. Okay, so that is how we get the reduced model and nested models. Okay, so if the question says that after using the maximum likelihood estimation, okay, these are the maximum log likelihood values that are obtained. Okay, so for the reduced model, log likelihood, okay, log likelihood is equal to small l r. Okay, it is log likelihood, not likelihood. Okay, is equal to minus 120.5. okay, and the full model log likelihood, small l f, okay, it is equal to minus 112.3. okay, now there are basically 4 questions that are being asked. Okay, the very first question is to clearly state the null hypothesis and alternative hypothesis. So null and alternative hypothesis. Okay, it says that to state the null and alternative hypothesis. To check whether the additional explanatory variable significantly improves the model fit. Okay, so for that we need to state the null and alternative hypothesis. Okay, for testing whether the additional explanatory variable significantly improves the model fit. Okay, then the B is that define the likelihood test ratio test statistics. Okay, define likelihood ratio test statistics. Okay, and compute its value. Okay, the C question that is asked is to state the sampling distribution. Okay, state sampling distribution of the likelihood ratio test statistics under the null hypothesis and specify the appropriate degree of freedom. Okay, so sampling distribution plus the degree of freedom. Okay, and D is at 5% significance level. Okay, determine whether reduced model is adequate or not. Determine whether reduced model is adequate or full model is better. Okay, we have to conclude it. Okay, so these are the 4 things that need to be defined, explained and solved. Okay, so let's start with the very first question, which says that state the null hypothesis. So the very first is to just define the null and alternative hypothesis. So the null hypothesis is that reduced model is sufficient. Okay, and alternative hypothesis is that full model fits better. Okay, so this is the hypothesis. Okay, B is the defining the likelihood ratio test statistics. Okay, LRT stats, these need to be defined. Okay, so we know that the likelihood ratio test statistics, it is equal to -2 into small the log likelihood for the reduced model minus log likelihood for the full model, and these two values are given to us. Okay, so when we put the value, we get 2 into, let's put these values which are given to us. I would have written it somewhere, these. Okay, so reduced model is -120.5. okay, so minus 120.5 minus 112.3, this one. Okay, so what we get is, we get -2 into 120 minus 112 and 0.5 minus 0.3, so we get 0.2 and 8.2. Okay, so this is minus. Okay, and this value is also, LF is also minus. Okay, so it will become plus. Okay, minus multiplied by minus, it equals plus. Okay, so minus 120 plus 112.3, it will we get 8.2. Okay, so the total value we get is sorry, minus 8.2, because the minus 120 is bigger and it has minus sign. Okay, so minus 8.2, so the total value is 16.4. Okay, so this is the likelihood ratio test statistics. Okay, now we will do the third part also. Okay.